Yes, folks, Hume again, how are you going? So we come to yet another video in our ongoing series where we discuss the circle, we discussing the properties of a circle, we discussing certain theorems pertaining to the circle itself. All right, and in this video we're going to discuss my theorem 6 and 7. We already had 1 in one video, we had 2 and 3 in another video. We had 4 and 5 in another video, so this one will be 6 and 7. Alright, so my theorem 6, and I'm reading from the syllabus with some minor modification, is as follows. Excuse me, hold on. The angle between a tangent to a circle and a chord through the point of contact is equal to the angle subtended by the chord in the alternate segment. Let me read that again. The angle between a tangent to a circle and a chord through the point of contact is equal to the angle subtended by the chord in the alternate segment. Right? This is what we refer to as the point of contact. At higher levels of mathematics, we refer to it as the point of tangency. Same difference. Alright, so again, as always, don't get so caught up in the vocabulary that you lose the meaning. Alright, so what does that mean? Well, in this case, we have the tangent here at the point A. This is the point of contact, and we have the chord AB. AB is a chord. So the angle formed is this angle here. This is the angle formed. Let me read from the syllabus. The angle between a tangent to a circle and a chord. So this is a tangent here. Right? This is a chord here. Right? So AB is the chord. Right? I just drawing it in red just for reference. Just a highlight. AB is a chord. And this whole thing here is a tangent. Alright? So the angle formed by the tangent to a circle at the point of contact, boom, and the chord, boom, this here is the angle, is equal to the angle subtended by the chord in the alternate segment. So this takes us straight back to the very first theorem, where we would have said that the angle subtended, the angles, all angles subtended by the same chord on the same circumference in the same segment are equal. So what I did deliberately is that even though the theorem itself refers to just one angle, I drew 3 versions of that one angle just to drive home the point that it doesn't matter whether it's angle C or angle D or angle E. Once this chord subtends any angle in the alternate segment because the angle between the tangent and the chord will be in this segment. Remember, we have the major segment and the minor segment. Alright? So this here is the major segment, this here is the minor segment. So in this case, the angle being formed in the minor segment means that the angle subtended by the chord on the circumference in the major segment would be any one of these 3, and any angle on this circumference subtended by this chord will be equal to this angle here, this angle between the tangent and the chord itself. Alright? That's it. So in other words, I don't have to spend half an hour explaining the theory. And I don't have to repeat it over and over again. Thanks to the technology that you are employing right at this very minute to watch the video. Alright? The important part now is for you as a student to get the practice. And I keep saying that and I keep repeating that. Don't be satisfied just to look at the video and understand. Because the real test of the understanding would come when you have to look at a diagram that you would have never seen before. under the pressure of an exam situation and realize which angle is which and which line is which and blah, 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 blah. Boom. All right? Nice. So theorem 6 now. My theorem 6 says, no, 6 and 7. So that was 6. So we're on 7 now, right? 7, 8, and 9. Right. Theorem 7 says that a tangent to a circle is perpendicular to the radius or diameter of that circle at the point of contact. So in this video we're dealing with tangents, right? In the last video we dealt with cyclic quadrilaterals. This time we're dealing with tangents. So let me go again. A tangent to a circle is perpendicular to the radius / diameter of that circle at the point of contact. This again is one of the theorems that everybody latch onto very quickly because it's a simple theorem, right? Once you see a tangent and you have enough information to know that this OA is a radius, then immediately you know that this angle is a right angle. End of discussion, right? Let me put another letter here. B, AB, right? So AB is the diameter, O is the center. Now, it is usually the case that they denote the center of the circle by the letter O. That is usually the case, right? That is not something to swear upon. To say, well, it must be O. There's no law in the universe that says that they must denote the center of the circle in an exam by the letter O. Usually that is the case. And again, I want to drive home the point. Don't assume. So even if you go in a circles question, all right, question 9 in the C-Sec Math syllabus, and you see a circle, and you see a point looking like it in the center, and you see the letter O next to the point, do not assume that O is the center unless there is explicit information to that effect in the write-up to the question, or there is other implicit information in the question that will allow you to deduce that O is the center of the circle, right? One of the things I try to do all the time is to discourage students from making assumptions. Same thing with the right angle. There will be times in a circles question when you have an angle that's looking like 90 degrees, right? You as a student will be totally out of place to just say, well, angle ABC is 90 degrees. If you cannot justify that, you have to be able to give you a reason. Reason X, reason Y, blah, 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 blah. That is what this question is about. This question is not about how the angle looking. It is about deducing what it is based on the information presented before you. A lot of things in life are like that. It's not always about how it look. All right? It's about what you have before you, and you figure out what it is based on what you have before you. A lot of things in life are like that. So again, I'm taking the opportunity now to drive home some philosophy that you can apply outside of the mathematical sphere. All right? Boom. So that's it. So let me go through the two theorems again. All right? Theorem 6. The angle between a tangent to a circle and a chord through the point of contact is equal to the angle subtended by the chord in the alternate segment. Boom. Theorem 7. A tangent of a circle is perpendicular 90 degrees to the radius / diameter of that circle at the point of contact. End of discussion. And nothing else to say here again. What remains now is to do the questions and practice. All right? Textbook, past papers, internet, whatever. Yeah? So, as always, we have more things coming up. Come back. And when you come in, bring somebody with you. All right? Boom.